Hey guys, EveryTim here. I'm excited to welcome you to our introductory series on software testing, and in this video I'm going to be walking you through the basics of software testing. Make sure you are subscribed to my channel and you have your post notifications turned on so you do not miss subsequent videos that will be coming in on this playlist and on my channel. Thank you. So let's get right into it. In this video we are going to be talking about what software is, what testing is, what software testing is, and why it is so important. We're also going to talk about the steps taken in software testing and the various levels involved in software testing. So what is software? Software refers to a collection of programs, data, and instructions that tells a computer system or a computing system what to do. When we're talking about computing systems, we're talking about any electronic device that is able to take in data, taking instructions also, and apply those instructions on some form of data and also provide results as expected, right? So here I said that the makeup of any computing system can be broadly classified into two categories. That would be hardware and software. But of course, this is a software testing tutorial, so yeah, we are mostly concerned about software. An example of software here can be a Python script that was programmed to take in two numbers, add them together, and display the results, maybe store them in memory. So a calculator can be a computing system, of course. So if we're trying to relate this to the definition of what a piece of software is, now we can see that this Python script takes in two numbers, right, to add together. Now these two numbers are what we refer to as data, and here the instruction is to add those numbers together. So of course a software program consists of what? Data and instructions. It's quite simple. Another application, another example is WhatsApp. WhatsApp is an application that was built to allow users chat in real time. So the data here could be the text you're sending, the media files you're sending, and the instructions would be, okay, send this message, put this on the status and all of that. Okay, so let's talk about testing. Testing is the process of evaluating an item to determine if it meets its specific requirements or not. Now in this context, when we are talking about requirements in software development can be broken down into two. We have functional and non-functional requirements. So what are functional requirements? Functional requirements refer to these functionalities that a software application must have in order to serve the needs of its users. So basically, functional requirements are the things that you are building a software application to provide. Do you understand? And non-functional requirements, on the other hand, refers to performance, usability issues, or other qualities that a software system must provide in order to be acceptable to its users. So what is the difference between functional and non-functional requirements? Take for instance, you build an app that allows people to save pictures, right? A functional requirement would be, okay, let users be able to save pictures, right? But now a non-functional requirement would be the application must be fast. Do you understand? So basically, functional requirements address the needs of the users directly, while non-functional requirements affect usability issues that allow that system to be usable and function properly. So what is software testing? If we put together the definition of software and the definition of testing that we just gave, then we can boldly say that software testing is the process of assessing software to see if it complies with its requirements or acts in accordance with expectations. So basically, as a software tester, your job is to make sure that a software system meets both its functional and non-functional requirements. And why is software testing important? Software testing is important in order to find flaws or errors in a software program and to make sure that it satisfies the requirements of its users. A very famous example of why software testing is important is something that happened in 1985. So these guys were supposed to launch a rocket. It was called the Ariane 5 rocket, if I'm not mistaken. Now, everything was done, everything was built, and they were set for the first launch, right? So just about 40 seconds after the first liftoff, the rocket exploded mid-air, and it cost the company over $7 billion. And at the end of the day, when they investigated the root cause of the explosion, they found out that there was a very little error in the software system, right? It had to do with something regarding conversion of floating point numbers to integers and all of that. Now, this little error, because the software system that was powering that rocket was not properly tested, It caused them to lose a lot of money. Imagine that rocket system was carrying people, they would have lost lives too, you understand? So software testing is very important to make sure that your system meets its needs, both functionally and non-functionally. So let's talk about the steps taken in software testing. This is very similar to the steps taken in software development. For people that have some experience in software development, we know about the planning, analysis, design, and all of that. So in software testing, we have these steps that you take when you're trying to test a piece of software: testing, design, test execution, defect tracking and reporting, and test closure. So what is test planning? Test planning involves defining the test objectives, the scope, the approach, and as well as the resources and tools that you use to test a software system. So basically, if you are called to test a software system, before you jump into it, the first thing you have to do is plan your test. Okay, what tools am I using? What am I looking out for? What am I checking? And all of that. Anyways, so let's talk about test design. In test design, what we do is we create test cases and scenarios based on software requirements, and we also select appropriate testing techniques and tools. You might want to ask what test cases are. Now, test cases can be referred to as simulations of processes that should happen in an application when it is in use. But you, as a software tester, you try to create these processes. You try to simulate these processes and try to test to see if it's going to work. Say, for instance, you are testing an application that involves payments, say an e-commerce application that involves payments, right? Say card payments. Now, when you can create a test case by yourself, you try to simulate a credit card payment on the platform to check whether it is working as it should work before the application is released, to be sure that you won't have issues or your users won't have issues when the application is in use. So let's talk about test execution. After you must have planned and designed your test cases and all of that, now you run your tests. So during test execution, you run your test and then you record your results. Whatever flaws or defects you must have found during your testing processes, you record everything. The next step is defect tracking and reporting. This involves logging and tracking the defects or issues that were identified during testing, as well as communicating them to the development team for resolution. So this is where you use some kind of tools. As we move forward in these tutorials, I'm going to be exposing tools that you can use in software testing. So here you use these tools to record and log the defects that you found in the application, and then you report them to the development team so you can find a way around it. And the final part is test closure. This is where you review your test results, you document the lesson learned, and then you prepare a test summary result. Not to worry, as we move on with these tutorials, I'm going to show you how to prepare all of these documents. So let's talk about the levels in software testing. The lowest level in software testing is what we call unit testing. So let's talk about the levels in software testing. The lowest level in software testing is unit testing, and it involves testing the lowest or the smallest units of a software system, which can be methods, functions, classes, and whatever we call them. Most times, unit testing is done by the software developers, the programmers that are writing the software in itself. So in unit testing, you test functions, you test methods and classes to be sure that the basic components of your software system are functioning properly. I mean, if the foundation is shaky, trust me, your application is going to be a big mess. So let's talk about integration testing. In integration testing, what we do is that we test the interaction between basic components or modules of a software application to see if they are coupled and they're working together as expected. An example could be testing to see if a website, for instance, communicates properly with its database. You could check for concurrency and a lot of stuff. Another level to software testing would be system testing. Now, in system testing, you test the entire system application as a whole to ensure that it meets its functional and non-functional requirements. Now, examples of system tests can include testing the user interface, testing the performance of the system, load testing, security testing, and all of that. Now we go to acceptance testing. In acceptance testing, what we do is we check the user's expectations, and then we check the functionality of the application, and then we try to see if they tally. Basically, in acceptance testing, we check to see if a user is going to use an application. Let's see if their expectations are met, right? Examples of acceptance tests includes user acceptance testing, usability testing, and exploratory testing. Don't worry, we are going to cover all of these terms as we move on in these tutorials. Up next, we have regression testing. Now, regression testing involves testing the software application after changes have been made to ensure that no unintended consequences have occurred. Regression testing, put in context, can be this way. Say you tested a piece of software and then you identify a particular defect and you report it to the development team, right? Now, programmers are very familiar with what we call breakage in code. Someone will tell you, oh, I was trying to fix this bug and then I broke the code. So in regression testing, you're just trying to check if in the process of trying to fix one error that you identified, or in the process of trying to add a module or a new functionality to a software system, you have not mistakenly touched something and spoiled it. Now, examples of regression tests include retesting a feature that previously worked after changes have been made to other parts of the application and ensuring that a previously fixed defect has not reoccurred. Now we have user acceptance testing. This is a type of testing that is performed by the end users or customer representatives to ensure that the software application meets their needs and expectations. So basically, this is more like when you're done with your application, you put it out there and then you have people assume the roles of end users and you get them to use your application and see if the application is working as intended. Examples are beta testing, field testing, and pilot testing. Like I said earlier, don't worry, as we move on with these tutorials, I'm going to be explaining all of these terms. Thank you so much for your time. Please leave all questions in the comment section, and you can also let me know what level of software testing you are most interested in. Thank you.